Hi students, welcome back to geometry. This is Mrs. Brunk again. Today we're going to be starting off on a brand new unit, module I guess, all about lines. Different kinds of lines, intersecting lines, parallel lines, perpendicular lines, and things that are related to lines. So in our first lesson, we're going to be focusing on angles formed by intersecting lines. And our learning goal is that you will be able to identify and use the properties of vertical, supplementary, and complementary angles to find the measure of angles or the value of a variable. So let's take a look at this little introductory example. Here we have two lines that are intersecting. And when they're intersecting, they share a common point. So an angle, the measure of angle 1 that's formed is 120 degrees. Now we're asked then to find all the rest of the angle measures. Well, how are we supposed to find the other measures when they only gave us one? Well, if we think about some of the things we've learned about angles, one angle that I see here in this drawing is a straight angle. Remember, a straight angle is an angle that is 180 degrees. So this angle right here is actually made up of two smaller angles, angle 1 and angle 2, and that's called a linear pair. So that's another term we've learned, right? And because these two angles together make a straight line or make a 180 degrees, we know that their measures have to add up to that. So that leaves 60 degrees for angle 2 to be, because 60 and 120 is 180 degrees. Now, keeping that same thing in mind, I could, let me just figure this out, I could look at the straight line over here and the linear pair that 1 and 4 make together. So you can also tell that angle 4 must be 60 degrees for that exact same reasoning. And then finally you could again move that straight angle, and this was 60, remember? And we could look at right there another straight angle and another linear pair. And because this angle is 60 at 4, then the one at 3 must be 120 degrees. So it turns out that 1 and 3 are both 120 degrees, and 2 and 4 are both 60 degrees. Now 1 and 3 and 2 and 4 are special kind of angles. They are angles called vertical angles, and they're vertical angles because they're made by two lines, intersecting, and they're the angles that face in the opposite direction that are formed by those exact same two lines. So you've been measuring vertical angles and linear pairs of angles. Actually, you've been finding them. When two lines intersect, the angles that are opposite each other are vertical angles. So again, they're the ones that would be facing in opposite directions. Like this is a pair of vertical angles, and then the ones at 1 and 3 are also vertical. And the vertical angle theorem says that they must be equal in measure. So you can see in this particular drawing, the angle 1 must be congruent to 3 and angle 2 must be congruent to 4, just like in our introductory example. And I guess these would have been measuring if we hadn't already given you that was 120 degrees. So we were really finding these angles, not measuring them. But we could see that the opposite ones in those vertical angle positions were congruent. So we're going to see if we can apply what we know about the vertical angles now and linear pairs and whatnot, and see if we can answer some questions. So cross braces help keep the desk post straight, or desk post. So there's a desk there. That looks more like a patio, but okay, who's going to judge? That looks like a deck, not a desk post. I should say deck post. Find the measure of each angle. So you can see that they've given us this angle here at 146 degrees. And so we know that the two angles next to 146 degrees would be the rest of 180, which I believe is 34 degrees. And then we also know that the angle in the opposite position, so the vertical angle that goes with that, is angle 6, so that will also be 146 degrees. So that's for A, so if they actually gave us these values. So let's say now that the measure of two vertical angles are 58 degrees and 3x plus 4. So we've got, let's say if we draw a picture of this, we've got some vertical angles. And we know that they're vertical, and one of them is 58 degrees, and one of them is 3x plus 4 degrees. Well, what we know for sure, which is always true, is that vertical angles are always equal in measure. So we could just simply write an equation that says that they're equal and find out what x is then. So we could say that 3x plus 4 is equal to 58. And then we could just follow our steps to solve. We could subtract 4 from both sides, giving us 3x equals 54, and then divide both sides by 3. So let's see, 3 goes into, 3 into 54, you can certainly use a calculator, but 3 goes into 5 one time, 2 left over, and 3 goes into 24 8 times, so that would be x equals 18. And that's really all they ask us to do, is find the value of x. Now if we were to take that 18, plug it back into that expression 3x plus 4, we should also get 58 degrees because those angles are congruent. Okay, so what about this one? The measure of two vertical angles are x plus 3 and 2x minus 7. So again, if we wanted a picture of what that would look like, we've got some vertical angles. We don't know which angles they're referring to. We don't even really know what these measures are, so this is sort of just a sketch for us to label. So let's say we said the one on top is x plus 3, and the one on the bottom is 2x minus 7, or we could have put them on the side. Either way, they're vertical angles, and so they have to be equal in measure. That's how we would mark that. And then we can say that in an equation then, that x plus 3 is equal to 2x minus 7. And now we can simply just go through our solving steps. We could subtract x from both sides to start. We could simplify them to 3 equals x minus 7. And then we could add 7 to both sides. And I definitely did not draw this picture to scale because it shows that x is 10, which actually means that this angle right here would be 13 degrees. And clearly that is not 13 degrees. But remember that the drawing is simply for us, for just reference. So we know our two angles. The angles are 13 degrees. And of course the other one is also 13 because 2 times 10 is 20 minus 7 is 13 degrees. So each angle, they're 13 degrees. So recall what you know about complementary and supplementary angles. And you may remember when we first learned about complementary angles and supplementary angles, sometimes people have trouble keeping them straight, and knowing the difference. They mix one up for the other. And one of the ways to remember this is always to remember that it's always right to complement someone. So in other words, complementary angles together make a right angle. And remember, a right angle is 90 degrees. So we know that complementary angles are two angles that add up to 90. And so that's our complementary angles here. Whereas our supplementary angles add up to 180 degrees. So they might be two angles that if they happen to be touching also, like connected, they would make a linear pair. But to be supplementary, they don't actually have to touch. They just have to add up to 180 degrees. So the first example says use the properties of vertical, complementary, and supplementary angles and use the diagram below to find the missing angle measures. So this is where we want to make sure we're just drawing on our picture and labeling everything we know. First of all, we know that the angle that was given is 50 degrees, so we've got that one. And we're trying to find CFD. Well, actually, CFD, if they're asking for that one, that's this angle right there. And we can already tell that that's 90 degrees because that makes a right angle. So let's see, I'll highlight this next one in a different color. So they want, let's see, angle AFE, the measure of angle AFE. So start at A, go on through F, and then to E, like that. So the next one they want is that angle right in there. So that's, if we can kind of work our way around this drawing and label what we know, then we'll see if maybe we can figure out what AFE is. So the angle that is next to this 50-degree angle would have to be 40 degrees. And the reason why is then you've got all three of these angles right here. Oops, all three of these angles that have to make 180 degrees together, right? So if we had 90 here and 50, then 40 more to make 180. Well, then this angle right here and this angle right here are vertical angles. So we know that this angle over here has to be 40. And then because we can tell that AFE, which is what I'm trying to find, and this angle that I just said was 40, make a linear pair, they must be supplementary. And that means that AFE must be 180 minus 40, which is 140 degrees. And I guess we could have even done that without finding the vertical angle that was 40, because we also have a straight angle that goes right here. Right? There's a straight angle right here for these two. Okay, so labeling is super important. AFB. So AFB was that one that we found, was 40 degrees. Okay, that one was right over there, right? Oop. There we go. That one was 40 degrees. And then DFE. So DFE was the one that was across from it, that other vertical angle. That one's also 40 degrees. So next, they want us to use the same drawing, but they give us some different measurements of the angles. And actually, they give them with variables. So I'm going to go ahead and I'm going to erase this drawing, and I'm going to reuse this. We do this a lot in geometry, where we'll give you one diagram and we use it for multiple different questions. So you could always just resketch it if you've already labeled yours and highlighted it and whatnot. So DF or DEF. So DEF. DEF. That's weird. I wonder if this is not even actually supposed to be with this drawing. Let me see. Actually, I think this is just a coincidence that the labels are similar, like DEF, but that DEF is not even an angle in this drawing, because E, you can tell, is not a vertex of an angle. So this is just two angles that we're told are complementary. So that's all we know about them. They're not in the drawing or anything. So what we know for a fact is that they add up to 90 degrees together, right? If I add them together, they're 90 degrees. So that's what I'm going to say. I'm going to say DEF, which is 3x minus 4, and FEG, which is 5x plus 6, must equal 90 degrees together. Okay? So they want us to find the measure of both angles. So we know that they both have to be under 90 degrees, right? But that we want to be more specific. We want to know exactly what their measures are. And so we'd have to solve this. So step one is to simplify our equation. It means we're going to put our like terms together. We have 3x and 5x. That makes 8x. We have negative 4 and positive 6. That makes plus 2. So this is our new equation. And now we can start solving. If I subtract 2 from both sides, that leaves me with 8x is equal to 88. Divide both sides by 8. And I can see that x must be 11. And that means I can take that, plug it in, and that will help me to find both of these angle measures. If I plug it into 3x minus 4, that would be 3 times 11, which is 33, minus 4, that's 29 degrees. And I could just figure out the other angle by subtracting 29 from 90 degrees, but it might be better if I actually plug it in and make sure the angles add up to 90. So 11 times 5 is 55, plus 6 is 61 degrees. And 61 and 29 equals 90. So that's a good way to check it, is plug it into the two separately and then make sure they add up to 90. So next we have these two angles, same names, DEF and FEG, and again we don't really have a drawing to go with it, but now we're told they're supplementary. So remember, supplementary means these are angles that are going to add to 180 degrees. So I've got these two angles, that angle plus that angle right there has to equal 180 degrees. And then they tell me that DEF is 9x plus 1. And then they also say that FEG is 8x plus 9, and I know they have to equal 180 degrees together. So clean up my equation, and then I'm going to solve. So when I add 9x and 8x, that's 17x, and then 1 and 9 make 10. So to solve, I'm going to subtract 10 from both sides. And that's going to give me, let's see, 17x, and over here 170. And so all I have to do is divide by 17. And x has to be 10. So now to find the angles, I'm just going to simply take x, and that's 10, and substitute it in. DEF would be 9 times 10, which is 90 plus 1, that's 91 degrees. And 8 times 10, which is 80 plus 9, is 89 degrees. And we know that 91 plus 89 adds up to 180 degrees. So that's a check. My two angles are 91 and 89 degrees. And one final example. So you can represent the measures of an angle and its complement as x and 90 minus x. You can represent the measure of an angle and its supplement as x and 180 minus x. It would make more sense if maybe we had numbers. Let's say x was 10, then the other angle would be 90 minus 10, or 80 degrees, right? So, but if we don't know either one of the angles, but we just happen to know that they're complementary, we would say something like one was x and the other one would be 90 minus x. So you can represent the measure of an angle, supplement as x and 180 minus x, and then complements x and 90 minus x. Use this to answer. So the first part, it says the measure of an angle is equal to its complement. So if we use this information about an angle being called x and its complement being 90 minus x, what we're really saying in this particular problem is that x must equal 90 minus x. Now you may not even really need to solve an equation to figure this out. If an angle is equal to its complement, that means you have two angles that are the same that add up to 90. You'd know each one has to be 45 degrees. But just to show you this equation does work that we wrote, we could add x to both sides, and then now we have 2x is equal to 90, and divide by 2, that means x must be 45 degrees. So one angle is x, that's 45, the other is 90 minus x, that makes 90 minus 45, and they're both 45. How about the second part? So the measure of an angle is twice the measure of its supplement. So a measure of an angle is twice the measure of its supplement. So first of all, we said we're going to call the angle itself x. So the measure of an angle x is, and is mathematically means equals, twice the measure of its supplement. So twice the measure of its supplement, I could say 2 times the supplement. Well, the supplement to x is 180 minus x. So that gives us a little equation that we could use. I just took and translated that from words into an algebraic equation, using the fact that if you have an angle, that its supplement will be 180 minus the angle. So let's go ahead and solve this real quick. So when I want to solve, I'm going to distribute the 2 through. So I'm going to take that 2 and I'm going to distribute it through to both of these. And that means x must be equal to 360 minus 2x. So now I'm going to add 2x to both sides to solve. So if I add my 2x over here, add my 2x over here, that's going to leave me with, let's see, that's 3x equals 360. And if I divided by 3, and I'm running a little bit out of space here, so maybe I'll reorganize this other side. So if I were to divide both sides by 3, I'd get x equals 120 degrees. So let's see if this makes sense. So if x is 120, and it's supposed to be twice the measure of its supplement, well, the other angle, its supplement, would have to be the rest of 180, which is 60 degrees. And so, yep, that makes sense. The original angle is twice what its supplement is, because twice 60 degrees is 120 degrees. So that does it for our little introduction to working with complementary and supplementary angles and vertical angles that are formed by intersecting lines. Thanks for coming to class.